right? So you are going to perform write operation. You are going to update the value of data item capital A. Then again you are going to perform a read operation. You are going to load the value of data item capital B. You are going to update value of B, right? You are going to credit $50 onto the account B, and then you are going to perform write operation, right? So let us now consider each of these asset properties for this transaction, right? So let us first consider this atomicity property, right? So suppose that just before the execution of the transaction Ti, right? So at the beginning of the transaction, the values of the accounts A and B are going to be $1,000 and $2,000 respectively. Now, suppose during the execution of the transaction Ti, a failure occurs that prevents Ti from completing the execution of the transaction successfully, right? So further, the failure happened after the write of A operation has been completed, but before the write of B operation. So there is a transaction failure. It happens after write of A operation has been completed, but before the write of B operation is being done. So what should you do? So since atomicity property, you need to undo the effects of the transaction, right? So in this case, the values of accounts A and B reflected in the database are going to be $950 and $2,000 respectively. The system has destroyed $50 as a result of this failure, right? So in particular, we note that the sum of the accounts A and B is no longer preserved, right? So how to ensure the atomicity property is like the basic idea behind ensuring the atomicity property is that the database system keeps track of the old values of any data on which it performs the write operation. So we are going to manage a log file. So whenever there is a write operation being carried out, we are going to store this information on the file log, right? So if the transaction that does not complete its execution, the database restores the old value from the log to make appear as if the transaction has never executed, right? So we'll study something more about this later. So here the thing is that if there is a failure, what happens is like the values of accounts A and B are going to be only $950 and $2,000. The sum of accounts A and B before and after the transaction is not going to be same, right? So how to manage atomicity is that you are going to maintain a log file. So whenever you are going to perform some write operations on the database variable, you are going to write the information onto the log file, right? So if the transaction does not complete its execution successfully, the database system restore its old values from the log to make it appear as if the transaction has never occurred, right? So you will have some old value of A and the new value of A. So old value of A is going to be $1,000, and once you perform write operation, new value of A will be $950. So you are going to have a separate log file to maintain the old value of the variables A and B respectively. So if it is going to be successful, then we are going to update the database with the new values of A and B respectively from the log file. Else, if there is a failure, transaction failure occurs, then you are going to use the old values of accounts A and B to restore the variable to its old values, right? So next thing is about the consistency property. So the consistency requirement here is that the sum of accounts A and B must be unchanged by the execution of the transaction, right? So as I said in the beginning, the sum of accounts A and B before and after the transaction should be same. Money should not be created or destroyed during the process of the transaction, right? So without the consistency requirement, money could be created or destroyed during the process of the transaction, right? So it can be easily verified that if the database is consistent before the beginning of your transaction, the database should remain consistent even after the execution of the transaction, right? So this is the second property of your transaction. So the next property is going to be, I think, durability property is there. I think I missed isolation. Anyway, we'll study in detail about the different properties. So we'll also study about durability. Now we'll study about durability. We'll study about isolation later, right? So regarding the durability property, once the execution of the transaction completes successfully and the user who initiated the transaction has been notified that the transfer of funds have taken place, it must be the case that no system failure can result in a loss of data corresponding to the transfer of funds, right? So we have done a transfer of funds in transaction TI. So $50 debited from account A and $50 credited into account B. So there is a transaction failure after the completion of the transaction, right? So you receive some acknowledgement that the fund transfer has been done successfully. You receive an acknowledgement, and then there is a system failure. So no system failure can result in loss of data corresponding to the transfer of funds, right? So the durability property guarantees that once a transaction completes successfully, all the updates that it carried out on the database persist, even if there is a system failure after the transaction completion, right? So durability property guarantees that even if there is a system failure after the transaction completes successfully, all the updates that a transaction carried out should persist in the database, even if there is a system failure after the transaction completes its execution, right? So how do you implement durability property? So the durability property implementation, you are going to update both onto the variable as well as onto the disk file, right? So you are going to write the updates not only onto the database but onto your disk file, right? So even if the database fails, you'll be able to recover it from the disk file, right? So the updates carried out by the transaction have been written to the disk before the transaction completes, right? So whatever you do, update operation in a database to ensure the durability property, you are going to write not only onto the database but onto the disk file also, right? So information about the updates carried out by the transaction and written to the disk is sufficient to enable the database to reconstruct the update when the database is restarted from the failure, right? So whenever I perform an online ticket booking, there will be two servers, right? So we'll have both the database server and its backup server running. So the information will be written onto the database server as well as onto the backup server. So even if one server fails, I will be able to recover it from the other server, right? If I'm going to use some desktop for working with database, so it will be written both onto the database as well as onto a disk file. So I'll be able to recover the information from the disk file, right? So this is about working with how to implement durability property, right? So we have studied how to implement atomicity property and durability property also in today's class. So atomicity property, we are going to use a log file. So whenever you are going to write some whenever you are going to perform some write operations, you are going to write the information onto a log file. So log file basically contains the old values of the variable A and new values of the variable A and B respectively, right? So at any point of time, if the system crashes, you are going to replace the variable values with old values. However, if the transaction executes successfully, we are going to use the new values present in the log files to right. So this is about the properties of how acid properties are met by a transaction, right? So I think we have done with some 15 slides. So I think we have around 98 slides for this chapter. So I will make it in 5 or 6 classes. So as I said in the beginning, for CT2 we'll have both third unit and fourth unit.